on. Awesome. Can everyone hear me? Yes. Oh, it's good to be here. It's great to be here. I spent all day with about 25 of you doing a DevOps leadership workshop. And I must say, I think I learned more from all of you than you probably learned from me. So thank you to all of those that attended. Is there anyone here who attended the workshop? Yeah, there's a few of you. Great. I hope you had a great time. I certainly had a great time running that workshop. And I think that's really the essence of these DevOps talks, conferences, is that we can get so much from each other. And I hope that I can bring some thoughts to you today that you can leverage and that you can use. And feel free to reach out to me. So my Twitter handle is down the bottom there. Feel free to follow me. If you do follow me, you'll usually see photos of Nathan and I photobombing each other and things like that. We're always playing jokes. But feel free to follow me, and I'd love to keep in contact with you all after this. So I started putting together this talk. This is a brand new one. I haven't presented this one before, so bear with me. It'll be fine. Don't worry. It'll be fine. I guarantee it. Like, I give you a money-back guarantee on that one for my talk. Okay. But I started putting together the talk, and then once I finished it, I started thinking about whether the title that I put together for it was truly accurate. And it is accurate, but you could also look at it from a different perspective in that I've started to look at things from the coded enterprise perspective. And I'm going to delve into that more. I'm going to talk more about what I mean by the coded enterprise. But I really feel from the last couple of years, organizations, enterprises primarily, have really moved more towards doing everything by code. Yeah, that pivot has happened. Everyone is expected to be a developer of some sort, right? We're all expected to understand code at some particular level. And it's becoming more and more proliferant throughout the enterprises and the larger organizations. Do people feel that? Do you feel that pivot has started to come and that the developers are more proliferant throughout the organization? And it's not just the original dev teams. You know, your ops groups are look to be writing code. Your security teams are looking to be able to write code, all the way up the chain. And it's becoming more and more technical in an IT organization, which makes sense, right? You've probably also heard a lot of the CEOs over the last couple of years talk about, so I remember one of the CEOs of the airlines basically said, oh, we're an IT organization that happens to own airplanes, right? Those groups are starting to recognize that code is really the area that's going to change things. And so in line with that, we need to start thinking of things from a stack perspective, right? What's the stack? Well, the stack in this particular case is, what are you running something on? It's probably going to be some sort of infrastructure. There's something that's being run on somewhere around. How are we going to make it compliant? And what's the actual application which is running on top of that? And the reason why we're starting to think of everything as code on that stack is because we can manage those versions really easily. The whole idea of a source code management repository is that it's easy to be able to manage different versions, right? That's what it was invented for. I'm sure everyone in here, their organizations are using Git or a variation of it. Some of you may be using something like Subversion, but you're all using an SCM, a source code management repository mentality. And that allows us to be able to have multiple people working in the same domains, in the same areas. And it also means that we're very explicit, we're clear, aren't we? When we write things as code, they're unambiguous. They do a particular thing. And that particular thing is really important because it's really important that we get it right, especially as an enterprise organization. We can't afford to make mistakes. Fixing things in production or repairing things for our customers that have caused outages is a huge, huge issue these days, and it costs millions and millions of dollars. I don't need to tell you that if you have to fix something in production, as opposed to fixing something on your laptop, it's a lot cheaper to do that on your laptop than it is to fix it in production. And so using code and managing things through development life cycles and pipelines gives us control. And it's that control that we need and that we get from defining our stack as code. So if we were to explode that stack out, what does it look like? Well, we have a range of different areas, but sitting on top of that stack, right at the very top of that stack, sitting on top of the compliance and the operating system and the provisioning of that operating system and the configuration of that operating system is the application. And the application itself is really where the business value is. At the end of the day, if something goes wrong in an organization and the CEO or the CFO has to report on that, they don't talk about the particular operating system that it was running on or what you used to provision it. They use the name of the application. The application went down. All right? That's the name that they use. You know, organizationx.com was down on the weekend. Our website was down. Right? They don't talk about the technologies that we use to put that together. They talk about the app. And that's where the business value is. That's where the money is for them. And really, the sections that are sitting underneath that are supporting the application, are managing the risk for us. Right? They're managing that risk. The compliance side, making sure that something is compliant, that it's auditable, that it meets the standards of our organization, that's managing risk. The operating system, has it been patched correctly? Is it adhering to our organization standards? Is managing risk again. Provisioning, have we provisioned an image that is not end of life? Right? Have we gone and stood up something which is already end of life? That's managing the risk again, making sure that happens. And the configuration, making sure that we put the security in that we require. Adding that security layer in and ensuring that it meets the configuration requirements of our organization. You're not running something as root. You know, you're not using the administrator account on a Windows machine. All of those things are making sure that you're managing that risk correctly within your org. So if we are to look at the stack as code and take a look at our organization from top to bottom as a set of code, and looking at each one of those particular areas, and if we drill down into each one of these areas and we'll start from the bottom, we'll have a look at the compliance area first. We do have the ability to be able to define our compliance in a code-like manner. There's many different open source variants out there that we can use, but InSpec's one particular example that I'll bring up. And we can actually take recommended benchmarks, we can turn that into code, and we can run that code against our provisioners, the provisioning platforms themselves. We can run it against our on-premise data centers. We can run it against public cloud. We can run it against the operating systems. We can run it against the applications that run on top of those operating systems as well. And we can take that and we can turn it completely into a set of code which is then able to be checked into a source code management system. And then, of course, it becomes part of the development lifecycle. And the great part about that, of course, is that we can use test-driven development techniques to be able to use this. So the developers can then be collaborative with the security team. And the security team, together with the developers and with the operations group, you know, in a DevSecOps based arrangement, they can use this and they can write that code. They can contribute to it. Different teams can contribute to it, of course, because it's all checked into your code repository. We can do the same thing with our operating systems as well. I've had a lot of questions over the last couple of days about how to manage different images and things like that. And you want to do everything through a pipeline. You want to do it all as code. If you want to manage things through a pipeline, you want to manage things through code, then there's great ways to be able to do that as well. Here's another open source example. It's called Packer, from the HashiCorp family. And it allows you to be able to define your images, your instances, all as code. You can literally define them as code, and you can define the way that they're output. You can use the same set of code to define your images, but spit out different versions of that operating system. So you could have one that's capable of being able to run on a VMware environment, one that's spat out as an AMI, which will run on AWS, all from the same set of code. And those literally become artifacts in their own right. And really, this is what you're trying to achieve. You're looking to be able to write code that can test your compliance. You're looking to be able to write code that can then create the images that your organization needs in a pipeline. If you need to patch that image, you add the patch to the code, check it in, submit the pull request, and then the continuous delivery rig will then pick it up, run the code for you, and it will create the images ready to be consumed. Now, of course, that's for a green fields, right? That's if you're going to go and stand something up new. But if you need to be able to do the same thing for existing images and roll those images, you can use the same code to do it. It's one set of code, and you can update all of your images in the same way through a pipeline. Everything is code. What about if we keep moving up the stack for provisioning? There's a lot of different provisioners out there. If you're AWS fans, then of course you're probably using something like CloudFormation. If you're in the Microsoft world on the Azure platform, probably ARM. If you're a little bit more agnostic and you're using a little bit of everything, maybe you're in the Terraform world. This is an example of Terraform. If you're in the VMware world, then you're probably using some sort of blueprints on your VMware environment. Hyper-V has exactly the same way of being able to define things too. But the key here is that you're delivering or you're pushing out these images that you created in the pipeline using code and defining that as a set of code as well to be able to then push and submit those. And then if we move even further up the stack and look at the configuration is sitting on top of the operating system that you've just gone and created. It's sitting on top of what you've provisioned and the compliance that you've just set. We take all of that and then we can actually configure the way that image is working. And we can use a range of different tools. There's a range of different tools out there. This is a solved area, but you want to do it all by code. Then we come to the application itself. The application is getting a little bit trickier. Now, the application is a little bit harder because, of course, it has ties down into the libraries of the operating system and the application libraries in its own right too. And what we need to do there is we need to define what that application is made up of in terms of the libraries that it utilizes, and also how we go and build that particular application. And I'll talk more about that in a little bit more detail later. And you need to be able to do it across a range of different operating systems too. But you can define the whole stack as code, and that's the key here. Defining the whole stack as code. And if you have it as code, of course, then what you can do is you can build that code and you can produce artifacts. And those artifacts, you can store them in your favorite artifact repo, right? Yeah. Artifact repos like JFrog, right? Nexus. Some people use S3 buckets. Other people use FTP servers sitting underneath their desk. I don't recommend that, right? That's not a good artifact repository. But what you're trying to do here is you're trying to create repeatable builds, create those repeatable builds, all via code. And then once you've done that, you need to be able to deliver it. And the way that you deliver it is really where are you going to be able to take those artifacts from? Where are they going to be stored? So the whole key here to being able to automate the full stack is thinking about the tools that you're going to use, making sure that the code that they allow you to be able to write will give you the correct build state that you need in order to be able to deliver the artifact that you want to consume. Simple, right? And that gives you one way to production. And what do I mean by one way to production? I mean that it doesn't matter what environment you're using, whether it's from your laptop, through any of those environments right through to production, we only use one way. We always use one way. And that way is exactly what I just described there, where it's all defined by code, and we output the artifacts that we need. So it's pretty simple in terms of the pipeline. You write the code on your development and on your laptop, and it doesn't matter what coding language it is, right? It doesn't matter whether you're a Microsoft developer or you're writing some Node, some Java. You've got a legacy-based COTS application. We use exactly the same methodology. And then once you've written your code, you've done your git add, git commit, and then you've submitted your PR. Gets picked up by your CI pipeline. We checked it into our code repository. And once it's in the code repository and it's gone through the system tests, the lint checks that need to be done, run its unit-based tests, etc., and it's passed all of that, you're probably going to get one of your peers to review that code. All right. The review takes place, and everyone's happy with that. You'll get it picked up by Jenkins or Concourse, Atlassian Bamboo, depends on what you're using. Visual Studio Team Server, I think they changed their name again this year. I can't remember it right off the top of my head. I'll remember it after I get off stage. And then you'll run all of your automated functional and integration tests. And once that's done, you're going to spit out your set of artifacts that you need, what we just spoke about. All right. Those artifacts will be spat out literally as immutable artifacts, right? That's what you want. You want immutable artifacts. And then you can export them to your platform of choice, right? If you want to spit them out as a Docker container, we can do that. And that allows us to be able to then push those artifacts onto the platforms of your choice. If you want to run them on Kubernetes, there's no problems there. Run it on any of the public clouds or even your own internal data centers if you're using VMware or Hyper-V or bare metal as well. It doesn't matter because the artifacts literally are immutable and you can push them to the platform of your choice. The key really here is that you've performed the testing stages that need to be done. And even if you want to use a range of different platforms to be able to do that, you can still do that too. Not everyone can afford to have environments that completely mimic production all of the time. It'd be great if we could, but we just don't have that type of money, and we can't have those types of resources lying around. So if you want to use a combination of on-prem and cloud, or you want to use some Kubernetes, but you can't afford to have all of the clusters available at all of the time, then you can use, of course you can leverage some of the public clouds to be able to do that. And all of this you want to be reporting on. You want to push it into a dashboard that shows you all of this information. Because that's going to give you the feedback that you require. That feedback loop is really important. Sure, it's all stored as code and it's all in our code repo and it's being pushed through our pipelines, but you need to get that feedback. The feedback is what's going to tell you how you were delivering your time to market and things like that. That's the important stages. That's the important pieces of the puzzle that you're trying to understand. And the simple pieces of the puzzle are probably centered around more of the traditional pieces that we've known for a while. So the infrastructure pieces, we're all pretty familiar with the concepts of infrastructure as code. It's not really a new process these days. It's kind of a solved problem, right? It's been around for a long time now. It's the same with spitting out images. Creating images via code is very handy, but it's been around for a little while. It's kind of a solved problem as well. Some of the more trickier ones are centered around your compliance and also centered around the application automation. And they're probably the ones that I'm going to concentrate on the most. So the compliance as code part is interesting. I mentioned an open source project before called InSpec. And really, most organizations, their compliance, their audits, they look like this. Yeah, they're huge folders. They're not usually sitting on their side like that. They're usually put onto a bookshelf. Those bookshelves are often purchased from IKEA. And you usually have more than one if your organization's been around for more than a couple of years. Yeah, large, really big white folders put onto the shelf. Yep. And the ones on the left are collecting a lot of dust. The ones on the right-hand side, which are kind of newer, they're still really, really white, whereas the ones on the left-hand side are starting to get a little bit yellow from the sun that's been shining on them for a while. But they all look like this, especially if you put them on their side. And the information that's held within them is very similar to this as well. Yep, it's riveting stuff. Does anyone in the room suffer from insomnia? Yeah, I can give you a couple of these white folders to go and read. I guarantee you it'll fix your insomnia problem. No problem, no issue whatsoever. But in all seriousness, this is exactly what's contained within those huge binders, right? And the problem that we have though is that all of the product and our ideas and features are up here. And then we have this huge security review that we need to get over before we can get down into production where we're making the money down the bottom. Yeah? It's just, we're just stuck, aren't we? Yeah? Got all the fish up here just trying to get over that wall, right? How do I get down here? No one wants to go through the hydroelectric scheme. That hurts, right? And so we've really got a communication problem. Yeah. The developers are over here and they're writing code, right? We are writing code and we're checking it into source code repos. And the security group, yeah, they're writing code as well, but it's kind of different and we're not really talking to each other at all. And the compliance group that we just spoke about, they're creating Excel spreadsheets and white binder folders that are sitting on IKEA furniture. We're just not talking the same language whatsoever. And it kind of feels like this. Yeah, kind of feels like this. I stole this image from Nathan Harvey, so I have to credit him to it because he's in the room. If he wasn't here, I wouldn't tell you that I stole it from him. I'd claim it as my own until he saw this on YouTube and then he'd ring me up, so. But that's okay. But what we really want to do is we want to get everyone talking the same language, right? We want to get everyone writing code. And that was my point before. We want to play well together, right? That's the whole concept of this talk. How do we play well together? How do we write code and how do we play well together? Especially when we're talking about compliance, because compliance doesn't really fit that particular model, or does it? Well, you can write your compliance checks and you can write them as code. And it looks sort of like this. You basically take the checks that you want to be able to, that you need to be able to perform for your organization, and you write it using code. And it really shouldn't matter whether it's on a Windows platform or whether it's on a Linux platform, whether you're checking a database or whether you're checking an Apache web server, whether it's Oracle for the database or whether it's MySQL, you can still write code to be able to check the validity of all of those. And we can use industry best practice standards. We can use things and leverage standards like the Center for Internet Security as a basis. Right? Who's heard of CIS? Yeah, of course you have. All right. You all work for enterprises, and enterprises are held accountable to something. And most organizations will go and start with things like the Center for Internet Security. And then they'll generally have to iterate on that as well. Yeah, it becomes more complex because, of course, your organization has its own rules. So what do you do when your organization has its own custom rules? Well, that's fine. That's code. You just write your own set of code that goes along with it. You check it into your source code repository, and it goes through your CI/CD pipeline. It's easy. Everything is code. Things are a lot easier when you can check things into a source code repo. So let me jump over into my Windows machine that I've got here. And if we take a look at some of the code here, let's see if this is going to be big enough for you to read. So if we need to be able to scan Windows types machines, we can do that. We can scan them and we can check to see if they're patched correctly. We can check to see if packages and services are running or installed correctly on these machines. We can check the responses, the HTTP responses and the port-based responses as well from a security perspective. We can even get right down to the different protocols, et cetera, for the ports and what exactly is listening on those ports. We can do all of that, and we can describe all of that as code, even on a Windows system, which is really, really great. And all of this information can be continuously run against our operating systems and our databases, et cetera. It's all part of your CI/CD pipeline. But the best part about it is you can also run it locally on your machine as well. So the developers can test it before it even gets fully committed, before the pull request is merged, and before the continuous delivery rig picks it up and pushes it into development. We can test all of this. And the further left that you can shift anything, the quicker it is and the cheaper it is to achieve. So if we were to use this example and run these particular tests on a Windows machine, we can do that. And we can execute these tests continuously. And we can take all of the information and we can grab that information and we can use it in reports and send that information back to our reporting systems. All of that information can be put into reporting dashboards. They can be put into pretty reports. You know those audit groups that call you up every 3 months and tell you next week they're going to be on site to perform an audit? You can now send them their audit details every day. They don't need to come and see you anymore. You can send them all of those details. All of the audit requirements that they have, you can turn it into code and you can send them those reports. It can be an on-demand. They can turn up whenever they feel like. When they ring you and tell you they're coming in, you can say, no problems. I'll be out to lunch, but I'll leave you a link to the report with all of the tests that are passed. We can also do the same thing on Linux as well. And we have the ability to be able to do it not only using agent-based calls, but also completely agentless as well. This particular CentOS machine that I've got, I'm just going to hit it straight via SSH and pull back all of the information. And you can quickly see where things have passed and where they've failed. And that information can be pushed into reporting dashboards so that it's pretty and people can read it. But we're developers and we like looking at sysout and the standard output onto screens, don't we? Not really, but you get my drift. You can see all of this information. You can put it into your reporting dashboards. You can even pull it into systems like Splunk so that you can, your organization can crawl all over it and see those particular outputs. But the important thing is that it's all held as code, and all of that information is there for you to be able to then report back to your leadership and to be able to pass that information onto your auditors and your security teams as well. I always love telling the story about one of my customers. They're a Singapore-based customer, and they used to spend about 3.5 weeks preparing every quarter for their auditors to come in. They're a bank based out of Singapore, and that 3.5 weeks would usually start with 2 or 3 people during the first week, and by the time you get to the end of the third week, there's generally close to about 10 people from different groups within the IT organization of the bank preparing all of this information to be able to pass the audit, which they'd usually fail, by the way. So they'd spend all of this time and put all of this effort in, and they'd usually fail by about 20 or 30 checks, which they'd have to spend the next 2 or 3 weeks grabbing the information for and passing it through. And this was just going on and on. It was a cycle. It was a very depressing cycle too. Their manager has a direct correlation between sick leave and audits. Yeah, and that percentage would go up quite astronomically. So not only did they have an issue with having to do those reports, but generally speaking, the best people that they had to be able to prepare the reports were usually sick during that time, or for part of that time. Not for all of that time, but for part of that time, which made it even harder. And so they use this technique now as well. They turn everything into code, and they can literally, like within reason, they can literally have an audit at any particular time. That information is sitting there ready and waiting for them to take. So that's one example of how you can use code to be able to help you. What about application automation? Application automation. It's always interesting to think about the way that applications are built and the way that they're put together. And there's another open source project which is called Habitat, which you probably haven't heard of. And Habitat allows you to be able to build, deploy, and manage applications. But the interesting thing about Habitat is that Habitat will allow you to be able to take all of your dependencies, your transitive dependencies and your core dependencies, take that information when you build your application, And the immutable artifact that it creates includes all of those dependencies. So by including those dependencies, it actually means that you can run your application on a range of different operating systems where it's not tied to the actual operating system. So for example, we had a customer who was running SQL Server 2005. So that, yep, you can run that on Windows 2012 R2, no problems. That's going to be a bit of an issue for you in the next couple of months. Microsoft will be calling you about that. But they needed to be able to get onto newer versions of the operating system. Now, you physically can't install SQL Server 2005 on a Windows 2016 machine. So with Habitat, because when we package up that application, we package it up with all of the dependencies that it requires. So that's the operating system libraries, the application libraries, and the app itself. We don't have to recompile the app or anything like that. All we do is we perform a build, and we do that build in a clean room. Essentially, it's like an air-gapped environment that has no connection to anything outside of it. So if you don't provide it with the information that it needs, the build will fail. So because you have to provide it, and you have to explicitly provide all of the dependencies that the operating system needs, once you finish the build, you can then take that package and you can run it on Windows 2016 because it has the operating system libraries that it needs to run. So Microsoft can't, the operating system itself can't physically stop the app from running. It knows it's running. It can see that it's running, it's passing it the CPU that it needs and the RAM and the storage, et cetera, and everything else. But the application itself doesn't need the operating system for its libraries. So it physically runs without any issue whatsoever, essentially becoming semi-portable. And when a new version of Microsoft Windows comes out, so 2019 is due out in a couple of months' time, you'll literally be able to move it across onto 2019 as well. And the application is fully portable. It's now allowed you to be able to move it around. Even if you have a microservices-based architecture, it will give you a lot of advantages because it allows you to be able to do the same thing with the microservices architecture, be able to build the application, and then export it to the platform of your choice. So if you want to run it in Kubernetes, you can simply just export it to a Docker-based format, and then run it in Kubernetes. But the interesting thing that we found on top of that, both of those things are interesting, but the best part that we found about it was that if you've got an older application, even a COTS-based application, and you also have microservices that you're trying to leverage that type of technology and migrate it onto Kubernetes, you can actually use exactly the same pipeline methodology using Habitat, because you're building your artifacts in exactly the same way. So think about it. Gartner brought out an idea called bimodal IT a little while ago. And they basically said, well, if you're working on an older application over here, then you pretty much need to work in a completely different way to these people over here that are using Kubernetes and stuff like that. Well, I say you don't have to. You can actually have those teams working in a very similar model. In fact, using exactly the same pipeline technology approach and building their artifacts in an immutable way. Immutable artifacts is really the major and core advantages of leveraging systems like Kubernetes. And you can do the same thing with your COTS-based applications as well. You can build those applications. Doesn't matter whether they're old COTS-based applications or new world ones. Build those artifacts. And as soon as you've built them, you then have the ability to run them natively, or you can push them out or export them, so to speak, into a range of different support platforms. You can run them on bare metal or your VMs if you choose to do so. Or you can export them into compatible formats with Mesosphere DCOS, Kubernetes, straight Docker, or you can push it out and run it natively on any of your cloud VMs that you want as well. They essentially become a service in their own right. And as I said before, the way that we do that is because what we're doing is we're allowing the application, instead of building it from the bottom up, where we specify the operating system, we then specify the operating system libraries that are required, and the application libraries, and finally the application itself. What we're actually doing is turning it upside down, and we're building it from essentially the top down, which is quite different to the way that we look at the architecture of builds for applications. Because the application now includes the operating system libraries that it needs, and it includes the application libraries too. Essentially, making it immutable and portable. On top of that, the project also gives you the ability to be able to produce your artifacts and store them in a depot. And the depot gives you really great advantages because it can manage those artifacts for you. It manages them in what's considered to be a set of channels. And the channels, think of them really as tags, right? You're basically tagging them in terms of the version number and naming the channels in their own right. And then when the instances or the platforms that you're going to go and run your application require updates, they're essentially monitoring these channels. All you do is promote the new version to the channel that it's being monitored, and the application will go and update itself automatically. Essentially, it has a process supervisor. And the process supervisor has the ability to be able to run in a number of different ways. It can use a number of different topologies, so it can have leader standalone, or it can use a leader election-based model. You can also have different update strategies as well. So if you have horizontal scaling, you can have a couple of different rolling updates. You can do all at once. You can also do canary-based deploys as well, which is really handy. So it gives you a lot of flexibility. And essentially, the builder itself can be an on-premise based solution, or it can run, oops, wrong screen, didn't want to show that one yet. This is the one that I wanted. So what it can do is it can basically hold all of your versions. You can have it on-premise, or you can choose to have a SaaS-based version of it. And all of those different versions are held there, and basically all you're doing is, as the builds are being completed, they're sitting there in the channels. The channels are all versioned, as you would expect, and you can promote them from unstable to stable channels. So you can literally have different workspaces testing your unstable channels and making sure that they're all clear to move forward into your upper environments that would be considered on your stable channel list. You can even go to such extent to be able to have the ability for Habitat to manage multiple production instances of different versions. Let me give you an example. One of our customers has about 6,000 shop sites, and they can only update the applications in the shops once training has taken place for all of the workers that are on site at that particular premise. And so they can have 25 different versions all running in production at different sites, any one of those 6,000 sites, at any point in time. And they use this methodology to be able to manage it. They literally have channels which represent the new versions that have come out for them of the artifact itself. And then they promote the artifacts to the different shops. And that's the way that they manage the promotion. Once the staff have been trained in the shops, they then promote the artifact itself. And this allows them to be very granular in terms of what is deployed, when and where, and also allows the application to be able to look after itself. It literally deploys itself, which is the handy part. So, to wrap up, in summary, I always want you to think about using pipelines. I always want you to think about your applications, your compliance, your infrastructure, and the environments that they run on, and define them as code. You should always define them as code. I always want you to think about leveraging tools that allow you to be able to write things as code wherever possible. And if you continue to do that, of course, you'll have portable environments, and you'll also have environments which are controlled by your pipelines and your source code management repositories. I hope this gave you a different way to be able to look at the enterprise, especially from a coded way. I look forward to chatting to you all. Thank you very much for your time.